Hello everyone, this is the project presentation for CNT6805 Network Science and Application. The name of my project is Social Network Topology Analysis. Social network analysis is the process of investigating social structures by network and graph theories. It characterizes network structures in terms of nodes and the ties, edges, or links that connect them. Examples of social structures commonly visualized through social network analysis include social media networks, friendship and acquaintance networks, collaboration graphs, kinship, disease transmission, and sexual relationships. These networks are often visualized through sociograms in which nodes are represented as points and ties are represented as lines. In this project, my test data is downloaded from SNAP. Stanford Network Analysis Platform is a general-purpose network analysis and graph mining library. SNAP collects many datasets of social networks. In this project, I only focus on social networks. SNAP provides several social networks like social circles from Facebook, Google Plus, and Twitter. I choose to analyze Facebook's social circle because it has modest scale. There are 4,039 nodes and 8,234 edges in this network. The input file has two rows. The first is one user number while the second is the user number of a user that this user follows. I first convert this connection list into an adjacency matrix as the right picture shows. My first analysis is about degree. In this undirect social network, degree means the number of edges that incident on a node. In this project, I calculate degrees of each node and get distribution curves of degree, just like the left graph shows, and then I calculate probability distribution of node degree. We can see that most users of Facebook has less than 200 friends, while most than 50% of them have less than 100 friends. From this perspective, we can see that users mostly use Facebook to follow their friends in real life. Then I calculate clustering coefficient. In graph theory, a clustering coefficient is a measure of a degree to which nodes in graph tend to cluster together. Evidence suggests that in most real-world networks and in some particular social networks, nodes tend to create tightly knit groups characterized by a relatively high density of ties. This likelihood tends to be greater than the average probability of a tie randomly established between two nodes. This is the average clustering coefficient I get for this Facebook social network. And I also use a given naming algorithm to find out community information of this social network. Since the whole network is too large, I built a subgraph of the first 100 nodes in the original graph. In this calculation, I set the number of nodes as 5. And this picture shows the result of this algorithm. Then I calculate shortest path in this social network. I use Dijkstra algorithm to calculate the shortest path from one node to all the other. My program will return a matrix with one row and 4,039 columns. That's the number of total nodes, which records the length of shortest path from the start node to to every other node. Then I calculate a diameter. Diameter is the longest shortest path in a graph. We have to find out shortest path from every node in this graph to all others, and then find out the longest in this shortest path. here as the code of my algorithm. This is a result of calculation for diameter. We can see that the longest, shortest parts in this Facebook social network is 17. That's it. Thank you.